Good morning and welcome to this special edition of DCB News. This morning we will be discussing the topic of cystic fibrosis. Recently, Reading Hospital announced the opening of their new cystic fibrosis clinic. Now over to the hospital to learn more.
Thanks, Tamia. I'm here with Dr. Braswell Brown to talk about what cystic fibrosis is. Dr. Braswell, what exactly can you tell us about patients with this disease?
Well, Victoria, CF patients are mainly affected by frequent lung diseases that cause difficulty breathing and coughing up mucus. Patients also experience difficulties with their kidneys, pancreas, and intestines. Since the disease affects so many organs and bodily functions, a multidisciplinary approach must be taken when caring for these individuals. These multidisciplinary needs are one of the reasons a clinic specifically for CF patients is necessary.
Now, can you tell us who the most vulnerable is and how an individual becomes susceptible to this disease?
Yes, CF is a genetic disease and therefore must be inherited from an individual's parents. CF is caused by a mutation to the CFTR gene, which affects ion transport, mainly in the lungs. Individuals with CF are born with normal lungs, but within the first few years they develop unrelenting bacteria infections that damage their lungs. The severity of this damage is determined by the heredity of the disease as well as environmental factors.
Lastly, can you tell us more about what the inheritance pattern is?
Yes, so individuals have two copies of the CFTR gene, one from their mom and one from their dad. The CFTR gene is found on chromosome 7, an autosomal chromosome, which means that this disease is autosomal. The other type of inheritance pattern is sex-linked, which means the gene is located on the X chromosome. CF is a recessive disease, which means both copies of the CFTR gene must be mutated. If only one of their CFTR genes is mutated, the disease is not expressed and the individual is considered to be a carrier. A carrier can pass the mutated gene or normal gene on to their offspring with equal probability of either one being passed on.
The graphic currently being displayed shows two different scenarios of how an individual can be born with cystic fibrosis. On the left, both of the parents are carriers of the disease and have a 25% chance of having a child with cystic fibrosis. On the right, one of the parents has cystic fibrosis and the other is a carrier. They have a 50% chance of having a child with cystic fibrosis. If only one or neither of the parents is a carrier, then they cannot have a child with cystic fibrosis.
Thanks, Victoria and Dr. Braswell. We'll be back with more on cystic fibrosis after the break.
Welcome back to this special edition of DCB News. Dr. Braswell just informed us of how cystic fibrosis affects the individual's lungs and how an individual inherits this disease. Now, over to Tamia, who has met Dr. G at a genetics lab on NC State's campus.
Thank you, Victoria. I'm here with Dr. G, who is currently working in the genetics lab at NC State and hopes to learn more about the CFTR gene and its relationship with cystic fibrosis.
Thank you. The CFTR gene produces the cystic fibrosis transmembrane conductance regulator, or CFTR protein. The normal function of the CFTR protein is to serve as a channel across the membrane for cells that produce mucus, sweat, saliva, tears, and digestive enzymes. The CFTR protein is responsible for what goes in and out of cells in certain parts of the body. A missense point mutation in the DNA causes a deletion in one amino acid. This mutation in the CFTR gene results in cystic fibrosis. When the CFTR gene is mutated, it either produces less CFTR protein or none at all. This lack of CFTR protein causes mucus to build up in the lungs, which is displayed by the graphic you are currently seeing. This can lead to lung infections and damage to other organs. Thank you for watching this special edition of DCB News. We hope you enjoyed learning a little bit more about cystic fibrosis and how it affects individuals. Please stay tuned for next week's edition of Albinism in Frogs.